These are note 17. It is part of chapter 12-7 and 12-8. Feel free to look in your book, page 773 and 778. This is going to be about the discriminant and complex numbers. So this essential question is, how can I tell how many solutions there are to a quadratic, and what are complex numbers? So your warm-up should be done already. And it was about the quadratic formula, and the discriminant is part of the quadratic formula, so it's very related to the lesson. So, and I am providing questions on the left for you, so make sure you get that one copied. It has to do with the warm-up. How many solutions are there when there is a 0 in the square root? So we should have worked out this one using the quadratic formula, and then you would see how many solutions there are. And remember that when it's asking how many solutions there could be 0, or at least no real number solution. There could be 1 solution or 2. And I'm going to go over that right now in this beginning part of the notes. So go ahead and copy this down. I'll zoom it in a little bit too. So on page 773, it has this nice little note, and I didn't want to make you copy it all because it is right there in your book. So I'll show you that in a second. But write this down. It's a note about the discriminant. The discriminant is b squared minus 4ac, which is the part inside the square root of the quadratic formula. So it's part of the quadratic formula, but just calculating this part, so not having to do the whole thing, just calculating that inside part of the square root, it tells us if there are 1, 2, or no real number solutions. So let's look in the book real quick. 773. Let me just show you guys what that is. It's kind of hard to see. It's at the bottom, right there. Okay, so this is page 773 in your book. I highly recommend that you look at it, highlight it. Basically what it says is, if the discriminant, if the b squared minus 4ac comes out to be greater than 0, then that means when you calculate it, it's going to be positive, a positive value. And that means that there are 2 real number solutions. In the graph, it would look like this. You get 2 x-intercepts, wherever they are, but that's what it means. So if you calculate your discriminant b squared minus 4ac, and it's a positive value, if it's greater than 0, 2 real number solutions. If you calculate the discriminant and it actually equals 0, that's like our warm-up problem, then there is only 1 real number solution. I guess I should say 0. And that would mean that the vertex of the parabola is on the x-axis, and therefore it's only 1 solution. So if the discriminant equals 0, there is 1 real number solution. Sometimes, and we've done this with the quadratic formula, actually I don't know if you've had one that actually is negative. If we end up getting a negative value for the discriminant, if it's less than 0, we usually say, oh, there's no real number solutions. You cannot square root a negative value. So that would mean that there are no real number solutions. But what we're going to do in today's notes is learn what they are. They're not real number solutions, but we're going to talk about what that means when you have to square root a negative. So those are the 3 cases using the discriminant, b squared minus 4ac. And you can kind of see the quadratic formula. Just remember, it's this part right up here. It's the inside part of the quadratic formula called the discriminant. So again, if the discriminant, if inside the square root, if it works out to be a positive value, 2 solutions. If it's 0, 1 solution. If it's negative, no real number solutions. Okay, so you don't have to write that down. If you want to, you can, but I'm not going to. So all we're going to do is just real quick, and you have this on Math Excel, a couple examples of actually working that out. So make sure you pause if you need to so that you can copy this down. So what we need to do first is we're going to be doing b squared minus 4ac. Find your a, b, and c values, and then plug it into b squared minus 4ac. b squared minus 4ac. That is going to be, I'm going to switch to use a pen. So negative 6 squared minus 4 times a is 1 C is 7. Work it out, and we get 36 minus 28, and that gives us 8. So 8's not really an answer, but we have to analyze 8. Basically, you can look back at what the book was saying right here. It's a little blurry, but it's that first one. It's positive. We're looking to see, do we get a positive number, 0, or a negative number? So since it's positive, means that there are 2 solutions. I don't want to write it over there. So 2 solutions. And in MathExcel, that's kind of like what you would put. It's 2 real number solutions. Okay, so let's try the next one. X squared minus 6x plus 9 equals 0. As always, it has to be equal to 0 for you to find your A, your B, and your C values. Right, and then I'm going to go ahead and plug that into b squared minus 4ac. That's the discriminant. It's the inside of the square root part. B squared minus 4ac. And calculate it. B squared would be negative 6 squared minus 4 times 1 times 9. So I'm just plugging in the values. That would be 36 minus 4 times 9 is 36. That equals 0. So again, looking back into the book, that would be this middle one. The discriminant is 0. That means 1 real number solution. You can check by graphing if you want to. You could graph each one of these in Desmos.com. Remember to make it equal to y, or don't put the equal sign at all. And you'll see that there's 2 solutions here. The graph crosses the x-axis in 2 places. This one would be, I have just enough room right here to write that 0 means 1 solution. Okay, and then let's figure out this last one. So again, I'm going to plug in the values into the discriminant, which A is 1, B is negative 6, C is 11. Whoops. I'm going to plug it into b squared minus 4ac. I'm going to plug those in and solve and see what I get. So that would be negative 6 squared minus 4 times 1, c is 11, and I'm going to calculate that. So that would be 36 minus 44. That is going to be a negative value, negative 8. And so that means there is no real number solution. And that's based off of what the little chart in the book says. Let me also just highlight what we get each time. The positive 8 means 2 solutions. It could be any positive number. The 0 means 1 solution. The negative 8 means no real number solutions. And remember that that corresponds with a graph. Like if you were to graph it and how many places the graph intersects the x-axis. Again, it's right here. So we got negative 8. That means no real number solutions. The graph doesn't even cross the x-axis. Okay? All right, so that's a little bit about the discriminant. We can use that to tell us how many solutions there are. It's faster than calculating the whole quadratic formula. It's just the b squared minus 4ac part. Okay? All right, so now we're going to shift into the next part of our lesson, which is about imaginary numbers. This is about what happens when you have a negative in the square root. These no real number solutions, well, yeah, they're not real numbers, but there is something there. Okay, so there is a way to calculate these ones when there's no real number. So copy this down. I also put a picture or like an image of this on PowerSchool. This is, it's not the best. I mean, you could probably take up a whole sheet of paper to write down all the different sets of numbers, and I just tried to show it real quick. This is showing sets of numbers. So it says, now let's review sets of numbers. I encourage you to just Google sets of numbers and see what different kinds of sets there are. There are complex numbers, imaginary numbers, real numbers, irrational numbers, rational, integers, and I didn't have any space to put in the integers, but within the integers there are whole numbers and natural numbers. So there's a lot of different types of sets of numbers. Normally, what we have been talking about, just imagine that we like cover up this part. We don't even talk about these ones. So imagine that we cover that up. We have mostly been talking about real numbers. Two solutions, two real number solutions, one real number solution. Real numbers are irrational or rational. They include integers like the counting numbers and negative values. Rational numbers could be fractions or decimals, decimals that stop or decimals that have a pattern of repeating. Irrational numbers are those numbers like remember when we have square roots and we have to round to the hundredths place, those kind of numbers, or pi. It's values that keep going with no repetition and no, like a decimal that does not end. And they can be positive or negative. So we've been talking about real numbers, but there's this whole other kind of numbers called imaginary numbers. This is probably the first time you've heard about these. Make sure you guys get these questions on the left. I was just noticing. I helped you out today because I want you to think specifically these questions. How many real number solutions are there for 1, 2, and 3? For these examples, how many real number solutions are there? There was 2 or 1 or none. And then here on the left, put how do I simplify using I? So this is an I. We kind of just curve it at the bottom just to show that it is a special character. It's I. It's the same as like a normal I, but just to show that it's special, I guess. It's I don't know, we just write it kind of cursive-y, a little bit of a curve to it. So again, feel free to Google it and see what else you can learn about it. There's a lot out there. But just real quick, we are learning the very basics of it. So if you're curious, feel free to research it a little more. So there are imaginary numbers, which is a separate set of numbers from real numbers. Again, this might be the first time you've heard this. And so there's real numbers over here, imaginary numbers over here. All together in this whole sample space, they're all called complex numbers. Complex numbers could have like a real number and like adding or subtracting to it an imaginary number. So there's purely imaginary numbers, which would have an I after it, kind of like a variable. You always write the coefficient first and then the I. Or then you could also have real numbers, which don't have any imaginary number part with it. So what is an imaginary number? Don't overthink it. It isn't really that complicated. It is just I is the imaginary number. It's not a variable. It does stand for a specific value. I equals the square root of -1. So whenever you have the square root of -1, you can write that as I. And if you square it, I squared equals -1. We treat I as a variable, but it is not a variable since it can't vary. It is specifically equal to the square root of -1. So it says also we use I to make complex numbers, A plus BI, where A is a real number and then the BI part is an imaginary number. Okay, so pause if you need to if you're a little bit behind. Okay, I forgot that I whited this out. So write down number 4, it's the square root of -25. 5 is the square root of -100. 6 is the square root of -64. And 7 is 5 plus the square root of -4. So all we want to do is just simplify. How do I simplify using I? Notice right now in 4, 5, 6, and 7, there are no I's. I'm going to show you basically how to do this. All right, so this is how we simplify using I. Again, anytime we have a negative in a square root, it would be an I on the outside. If it was a value that I can actually square root, I would want to square root it. So if you have the square root of negative 25, normally we would say no solution. Let me just show you in the calculator. I would put 25 and make it negative. Then I square root it. It's an error. Your calculator doesn't know how to do imaginary numbers, or at least mine doesn't. So you can square root the 25 and then the negative 1 separately, kind of like this. And you don't have to write it all the time, but it's like negative 1 times 25. So you can square root the 1, and that would be I, and you can square root the 25, and it would be 5. Always write the number first, and then the I comes second. So all you have to do is write 5I. So again, the I comes from the negative. It's like square rooting a negative 1, and then you square root 25, which is 5. So if you don't know the square root of a number, like let's just say on this one, you're like, okay, there's a negative. I know there's going to be an I, but I forgot what's the square root of 100. You could just square root 100 and get that number, and then just don't forget to put the I with it. So number 5, again, you don't have to write this out, but it's like square rooting square rooting negative 1 times 100. And you just square root both of them, put the 10 first, and then the I next. So we've got 5I, 10I, and again, the I comes from the negative. If you're square rooting something and it's not negative, there's no I. You only get the I, the imaginary number, when you're square rooting a negative. So I think you guys would understand how to do 6. Give it a try. And if you're thinking that would be 8I, you are correct. And then number 7 is a little bit different. It's written as a complex number. So notice how 4, 5, and 6 is just the imaginary number part. But here we have a real number, 5, which is actually an integer, plus the square root of negative 4. So you can just rewrite that. The 5 stays as a 5, plus the square root of negative 4 would be, the negative part would be I, and the square root of 4 is 2. So it would be 5 plus 2I. And you can't add imaginary and real numbers together. It just stays in as an expression like this. So that would be the answer there. All right, so I need to turn the page. There's a few more examples, but if you need to pause it to finish this part up. And here is the rest. All right, so first let's look at adding and subtracting. So we can add and subtract complex numbers. The only thing is, remember that I is not a variable, but we treat I like a variable, like an X basically. So when you're adding, like on number 8, we have it's kind of like a binomial plus a binomial. You're just combining like terms. If there's a plus in the middle, you don't have to change any signs. You can actually just stack up like terms. The negative 3 adds with the 7, and the plus I adds with the negative 2I. So you could add it kind of like that. Or you could just think, use a different color, combine like terms, the 7 with the negative 3 and the negative 2I with the positive I. So there's multiple ways you could think about this. So anyways, 7 and a negative 3 makes 4, and then negative 2I plus I. Keep the i's the same, again, just like a variable, but you would think of the coefficients negative 2 plus 1, so that would be negative 1I. So our answer is this complex number, 4 minus I. All right, on the next one, number 9, it's going to be very similar, except we do have subtraction. So it's 1 plus 5I minus 3 minus 2I. And so we do need to distribute the negative and change the signs. If you remember doing that with other binomials, we do that sometimes whenever it's like this. So now it's going to be negative 3. I'll just mark it inside. So now it's going to be negative 3 and change that minus to a plus. So you can just combine like terms, 1 and negative 3. And then you can do 5i plus 2i. Or like I did in the other one, you could stack them up. It would be minus 3 and then plus 2i. So add them up, and we end up getting 1 minus 3 is negative 2. 5i plus 2i, just add the coefficients, and that would be plus 7i. So that's for addition and subtraction. For subtraction, remember, change the signs. Whatever comes after in the parentheses, change those signs. Okay, pause if you need to, but here's some more. This is going to be multiplying complex numbers. And remember that I squared equals negative 1, so we might have to simplify that. So remember, I to the second power equals negative 1. All right, so again, remember to treat the I like a variable. So on the first example, number 10, it is 7i times 3i. So you multiply the 7 times the 3 and get 21. And then I times I is I squared. And then we can't leave it like that. If it's just an I, like above, you can. But here, if it's I squared, remember that I squared is negative 1. So that is now the same. It's equal to 21 times negative 1. So basically, that's just negative 21. Okay. On the next one, it's 5i, parentheses 2 minus 3i. So imaginary number times a complex number. You do distribute. Again, just think of the I as a variable like an x, except if you get I squared, it is equal to negative 1. So I would distribute and multiply. And we get 5i times 2 is just 10i. 5 times 2 is 10, and the I stays the same. 5i times negative 3i would be minus 10, or sorry, 5 times 3 is 15, and then I times I is I squared. But then we have to do like what I did right here. 21 times I squared is like 21 times negative 1. So that's like 15 times negative 1, which is negative 15. So then I would get 10i minus, but then that's negative 15. So I have to change it to a plus. And I also want to write the real number first. So now there's no more I, so the 15 will come first. 15 plus 10i. Okay, so just be careful of your negatives. Anytime there's an I squared, it's going to change it to be negative. So it's minus a negative and it becomes plus. You also want to write the real number first and then the imaginary number second. That's how you always write complex numbers. Again, complex numbers would be a plus bi. Always the real number first and then the imaginary part second. All right, let's do these last two. So you can multiply two complex numbers together. It's basically like FOIL, if you remember, first, outside, inside, last, or just, or you just distribute. So I'll show distributing. First, you can multiply by the 6, 6 times 4, and then 6 times 5i. So we get 6 times 4 is 24, and then 6 times 5i is plus 30i. And then you can distribute by the negative 3i. Remember, take the sign in front. So it's negative 3i. Distribute that to the 4 and then to the 5i. So negative 3i times 4 is minus. 3 times 4 is 12, and the I is still there. And then we've got negative 3i times positive 5i. So negative 3 times 5 is minus 15. I times I is I squared. And we can't leave our answer like that. We have to simplify, combine like terms. So you do have these two like terms in the middle, the imaginary numbers, you just combine them. And then remember that the I squared is equal to negative 1. So I'm going to simplify a little bit. So the 24 stays 24. 30 minus 12 would be 18i, so plus 18i. And then right here, it would be a minus 15, but it's also times negative 1, so that's going to just change that sign. It would be like negative 15, so plus 15. And then I see I have like terms again. I can add 15 and 24. So combine those and always write the real number first and then the imaginary number, the plus 18i. So 24 plus 15 is 39. And that is how you do that. So again, you go through the steps of multiplying it out, doing distributing, or think about FOIL. You get your 4 terms, combine like terms if there are any. If you have an I squared, remember that turns into -1, and then that changes the sign. So if it was minus 15, now it's minus -15, so plus 15. And then we had like terms. Now you can't see that I added them. So 24 plus 15 is 39 plus 18i. All right, now number 13. 9 plus 4i squared. So just like a normal binomial, when we have an x, you can write this out 2 times. You don't just square the 9 and the 4i. You have to go through and distribute. So let me go ahead and show that. So again, if you have it squared, you have to write it 2 times and then multiply it out. 9 times 9, and then 9 times 4i. So that'd be 81. 9 times 4 is 36i. And then let me get my other color. Then you distribute by the 4i. So 4i times 9, and then 4i times 4i. So that would be plus 36i. And then 4 times 4 is 16. And I times I is I squared. Okay, so just like that other problem, we combine like terms, 36i plus 36i, 81 plus 72i, and then this I squared is going to be -1. So plus 16 times -1 would then be minus 16. And then combine like terms, 81 and -16, which is 65. So that would be our final answer. Write the 65 first, plus 72i, that comes second. All right, so remember you have a Math Excel to practice this. And don't forget to do your 3 questions on the left and a summary at the end.